Hey guys, happy Monday again. So today we're picking up where we left off last week. Last week we talked about aromatics and we talked about aliphatics. We said that aliphatic basically meant that it was a straight chain of carbons, no double bonds really. It was just carbon, 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 carbon. Namely, that aromatics had a benzene ring in them, which was that weird circle, or I'm sorry, hexagon that had the three double bonds inside. So today we're going to start talking about some of the aliphatics, in other words, these straight chain ones, and we're going to be talking about aliphatic hydrocarbons. By the way, psst, I'll let you in a little secret. Hydrocarbon just means a bunch of carbons with hydrogens. Hard, I know. So, first off, we're going to be talking about alkanes. Okay? In chemistry, an alkane is an aliphatic hydrocarbon that contains only single bonds. Okay? So there's no double bonds messing anything up. It's just a bunch of bond, 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 all just bonded together. Okay? Now, when we are looking at bonds, we're going to have to be able to figure out how to name what we're looking at. So these carbon and hydrogen combos, we need to know how to name them. So we have a little chart. There are 10 blanks on each side. Okay, so if you want to pause the video real quick and draw yourself a little chart that has a list of 10 blanks and 10 blanks, corresponding the number of carbons with the prefix we're going to use for the word. So these number of carbons, we'll just be listing 1 through 10. And then for the prefixes, we're going to give you a word for each number. So if you only have one carbon, okay? If you just have one carbon, your prefix is going to be meth. Okay? So this will just be meth. If you have two carbons, your prefix is going to be eth. If you have three carbons, then your prefix is going to be prop. Okay, I'm not going to keep writing these C's because it's going to start taking forever. If you have four carbons, it's going to be bute. If you have five, you will have pent. If you have six, you will have hex. If you have seven, you will have hept. If you have eight, you will have oct. If you have nine, you will have non. And if you have 10, you will have dec. So if you have this amount of carbons, this is what the word will start with. This is where you get things like methane gas, or propane gas, butane torch. That's where you're getting these words from. It's the number of carbons. Pause the video if you need to finish filling this out, and then I will move on. So, when you have carbons bonded with a bunch of hydrogens, there is a general rule we can follow. So the general rule is you'll take the number of carbons you have, multiply it by 2, and then add 2 to get the number of hydrogens. Here's the example. Let's say I have 4 carbons. Then what I would do is I would say, okay, 2 times 4 plus 2. What's 2 times 4? 8. What's 8 plus 2? 10. So I have 10 hydrogens. Or if I have 2 carbons, I would say, okay, 2 times 2 plus 2. What's 2 times 2? 4. What's 4 plus 2? 6. So I have C2H6. If I have 6 carbons, I say, okay, 2 times 6 plus 2. What's 6 times 2? 12. What's 12 plus 2? 14. So generally, you can follow this pattern to figure out, if you know how many carbons you have, you'll be able to figure out how many hydrogens you have, and this is a bit of a math shortcut. Now, why does this work? It's stupid for me just to give you a dumb equation like that and not explain. This is chemistry. We need to know why. Pause the video if you need to finish writing, and I am flipping the page. C4 looks like this, okay? C, 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 C. Now, how many hydrogen bonds can we have? Each carbon can have 4 bonds. So this buddy already has one, so he can have three more. This guy has two bonds already, he can have two more. This guy has two bonds already, he can have two more. And this guy has only one, so he can have three more. So how many hydrogens could I have? I could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could have 10 hydrogens, and guess what? That's what we already figured out. What about C2? C2 we said could have 6 hydrogens. Well, if I have 2 carbons, how many hydrogens could be bonded? They can each have 4. This guy already has 1, so we can have 3 more. And this guy only has 1, so we can already have 3 more. If I count, it's 1, 2, 3, 4, 5, 6 different bonds. C2H6. So this math is just a shortcut so you don't have to draw it out. But it'll give you the number of hydrogens pretty quickly. All right, so now that we kind of know how to name these suckers, let's talk about two terms we're going to start seeing. There's something called straight chain versus something called branched. All right, straight chain would look like this. Okay, carbons in a straight line. Branched would look like this. Notice both of them have 4 carbons. Both of them might even have the same chemical formula, but they're just in a slightly different version. The straight chain is in a straight line. Branched, one of them sticking off in some weird direction. Okay? Pause the video if you need to finish writing. Next thing we're going to define. An alkane group, remember what we said on the last page, was a straight chain of hydrocarbons. Now, what is an alkyl group? Well, we said alkanes were a set of hydrocarbons that only have single bonds. So an alkyl group is an alkane, but it's missing a hydrogen. Sad face, because nobody likes missing a hydrogen. So an alkyl group is an alkane group, but it's just missing a hydrogen. So let's say we had CH3. Well, given our little rule, we only have one C, so we'd multiply 2 times 1 plus 2. What's 2 times 1? 2. What's 2 plus 2? 4. It's supposed to be H4, but we're missing one. That means that this will be an alkyl group, and we'll figure out how to name those later. This one, we have 3 C's, so I'd say 2 times 3 plus 2. What's 2 times 3? 6. What's 6 plus 2? 8. I only have 7, I'm missing one. So this would be an alkyl group as well. So alkyl groups are just alkanes that happen to be missing a hydrogen. All right. Last piece we're going to be talking about is the different straight chain alkanes that are important to us. So the first one, methane. What does meth mean? Meth means 1. So that means we have 1 carbon. And he is surrounded by 4 hydrogens. Ethane. What's eth mean? Eth means 2. So that means I have 2 carbons, and they are surrounded by hydrogens. Keep in mind, each carbon can only have 4 bonds, so it ends up with this nice symmetrical shape. Propane. What does prop mean? 3 carbons. And those are all surrounded by H's. Butane. What does but mean? 4. And those are all surrounded by H's. I'm going to just draw the bonds. I'm not going to write the H's because it's going to take a long time. Pentane. 5 carbons. 1, 2, 3, 4, 5. And those will all be surrounded by hydrogens. So these are the straight chain alkanes that we're going to be acquainted with. So tomorrow we're going to talk about different alkanes and alkyl groups that are similar to these, but have a little bit of variation. So to summarize what we've talked about today, alkanes are groups of hydrocarbons, carbon and hydrogens, that are only comprised of single bonds. An alkyl group is those same things, but they just happen to be missing a hydrogen they're supposed to have. We also mentioned that a straight chain is a straight line of carbons going somewhere, and a branched group is one that has something sticking off in a random direction. Your Google Classroom assignment today is going to test your understanding of these concepts, and so get that done please today. And tomorrow we're going to talk about something called an isomer. God bless you guys. I'm praying for y'all. Here's to the start of a good week. Bye.